Dear students, we are now again going to interact in this course on geometric design. We have already started discussion on sight distances, and in the previous interaction we talked about the safe stopping sight distance, which is also being talked as SSD. And this SSD we have talked under the various conditions of carriageway and traffic movements, like the road is a single lane or a 2 lane or a multi lane, and the traffic which is moving on that is a unidirectional traffic or it is moving in both the directions. We also discussed about the effect of gradient, and then towards the end we have also incorporated one factor which is related to the braking efficiency, and we have seen that how this factor is going to make a difference in the calculations of SSD and what is going to be the distance by which the vehicle needs to be stopped before collision. In today's interaction, we are going to discuss about the overtaking sight distance. Again, in the case of overtaking sight distance, we will be discussing about the types of vehicles which are going to be involved. Now, when we say these types of vehicles which are involved, we are not talking in terms of whether bicycle or a car or a truck. What we are talking for overtaking reason, whether there is a vehicle which is slow moving or there is a vehicle which is fast moving and which is desiring to overtake the slow moving vehicle, and as well as there is a vehicle which may be coming from the opposite direction. So, if these vehicles are there, then how we are going to take care of these vehicles and how we are going to calculate the overtaking sight distance for given conditions is what we are going to look at. Now, when we talk about these vehicles, then there are few assumptions which are being made, and we are going to look at those assumptions also. Then comes the derivation, and this derivation we are going to look in the direction of Indian Road Congress, whatever are the guidelines which have been given by them. Then we will also compare the level section versus the sections with a gradient, that means the effect of gradient is going to be talked about. And finally, we will close today's interaction by discussing the overtaking zones. Now, let us start with our overtaking sight distance and what exactly is that. Now, when you look at a road and there are so many vehicles which are moving in the different directions, that means when you say that it is a 2 lane highway and there is a vehicle which is moving in this direction like this, or there is another vehicle which is moving in the opposite direction on the side lane. Now, all these vehicles like 1, 2 or say there is another vehicle 3, they may not be travelling at the same speed. If they are travelling at the same speed, then it means they are going with the lane discipline. They are maintaining the distances between the vehicles so that there is no collision. So, they may be maintaining SSD at a given speed, that is a design speed, and then that is going to be a very orderly movement of the traffic. But in the normal conditions, whatever we are facing on a road, this is what exactly is happening. And due to this reason, if there is a vehicle which is coming from the back and this vehicle is moving at a higher speed, then this fast vehicle will always desire to overtake the slow moving vehicles ahead and will try to go ahead in this way and will come back to the normal lane. Now, when this is going to happen, then there is going to be number of situations which can be there. Now, we have to look at the vehicles which are coming from the opposite direction. So, this vehicle which is coming from the opposite direction, and if there is a vehicle which is desiring to overtake like this, it should not happen that they are going to collide with each other. If this collision is going to be there, then this is a most hazardous situation which will appear on that road. So, we have to maintain the safety. So, this can be one thing which we have to take into consideration. Now, when we are looking at this aspect, it means the vehicle which is coming from the opposite direction should be at a distance away. So, that when the vehicle comes at this particular location, the another vehicle which was desiring to overtake has already done the overtaking and has come back to its own location. So, we are interested to look at those aspects, and therefore, unsafe situations has to be taken care of, and in that respect we are going to calculate the overtaking sight distance. Now, let us look at what is happening in the overtaking condition. This is a 2 lane road, and on this 2 lane road there is a slow moving blue color vehicle. Another vehicle which is white in color is trying to overtake that, but probably there is a problem of the perception. The driver of the fast moving vehicle has not understood the speed of the vehicles which are coming from the opposite direction, and you can see that what type of an hazardous situation would have been there. Subjective, the vehicle which is coming from the opposite direction has not moved into a kacha area or a shoulder area, and at the same time the blue vehicle has also not shifted towards the left hand side a bit. So, we are not looking at these type of overtaking interactions. What we are taking up is a safe overtaking interaction, and in this case we have a slow moving vehicle which is going to be overtaken. There is a fast moving vehicle which would like to pass the slow moving vehicle, and that means overtaking is going to be there. And of course, there is a vehicle which is coming from the opposite direction, and if your this road is having a single directional traffic, then this vehicle is not there which is coming from the opposite direction. So, we are not going to consider that, and that will happen in the case of the multi-lane divided systems also. So, in that direction, let us look at this divided carriageway system. Here in this photograph, what we find is that we have the multiple lanes on this side as well as on the other side of a median. So, we have a wide median which may be depressed, which is a kacha median at source, and then the vehicles are moving in these lanes. So, here there is no vehicle which is coming from the opposite direction here. All of these vehicles, they are moving in this direction, and therefore, the overtaking is going to be there with respect to these lanes. If we go by the terminologies and the normal assumptions, then the vehicles here should be the fastest, and the vehicles on the other side towards the shoulder should be the slowest one when they are moving in this particular single direction. If that is the case, then all of these vehicles will have an opportunity to overtake the slow moving vehicle, and for that they need to simply shift to the faster lane as compared to the another lane or the vehicle lane in which the vehicle is moving slow, and then just simply overtake. So, we will have what? We will be having a slow moving vehicle which is going to be overtaking, and a fast moving vehicle which will like to pass a slow moving vehicle. So, here there is no third case, that is there is a vehicle which is coming from the opposite direction. It is a more safer condition here. Now, let us look at this two lane carriageway where the overtaking or the passing maneuvers are going to be there, and with respect to this there are certain assumptions which we are going to talk further. We are not looking at a multi-lane system where, or a system where the number of vehicles which are moving like this, and there is a vehicle which starts overtaking, and then there is another vehicle which also starts overtaking. So, there are multiple overtaking conditions which are happening. We are at the moment not looking at this particular aspect. This is a more typical condition which may happen, but can be calculated on the basis of our assumptions and concept which we are going to talk. So, in this case what you can see is that there is a vehicle B which is a slow moving vehicle, there is a vehicle A which is fast moving vehicle, and there is a vehicle C which is from the opposite direction. There is also a location of a vehicle D. Now, this location of a vehicle D is again in the opposite side lane. Now, vehicle A which is moving in this direction and is being following the vehicle B which is a slow moving vehicle. Now, vehicle A desires to overtake, but what is happening is there is a continuous traffic which is coming on the side lane, other lane in the opposite direction, and it has been observed by vehicle A that when this opportunity is not there, that the vehicle has to move with the speed of the vehicle B, that is VB. So, vehicle A keeps moving with the speed VB for a certain distance, and that distance has been shown as the location A1 and A2, which is nothing but D1 in this sketch. Now, what is being observed by vehicle A is that there is a vehicle D which has already reached this location, and another vehicle is at location C1, and there is an ample gap, and because of this ample gap there is an opportunity to overtake, and so the vehicle shifts to the side lane, it starts accelerating and overtakes the vehicle, and during this time when this vehicle is accelerating and trying to overtake the vehicle B is still moving and it has reached another location B2. The vehicle A overtakes and then comes safely to location A3 while maintaining a gap between these two vehicles. And at the same time, the vehicle which is coming from the opposite direction, which was at C1 when the overtaking operation started, has now reached the location C2, and therefore, they are exactly opposite to each other, and that is the only safety which is there. So, there is no other safety margin. So, when there is no safety margin, it means the decisions being taken by the vehicle which is overtaking, the vehicle which is being overtaken, as well as the vehicle which is coming from the opposite direction, if all these drivers are not looking at the situations carefully, then there is always a possibility that something wrong may happen in this area. So, the various things which have been shown here is that, as I said, that the spacing has been maintained by the vehicle A with respect to the vehicle B. So, that is spacing is shown as S on both the sides. Vehicle B has been moving with a speed V B for a certain distance during this overtaking operation. So, that is being defined as B, and the combination of B and 2S is nothing but D2, and there is a distance which is being moved by the vehicle which is coming from the opposite direction and is being shown as D3. Now, let us look at what is these assumptions which we are talking now. I have already enumerated certain things there. We are going to look at those again here in this particular slide. The very first thing is that the overtaking vehicle follows the vehicle to be overtaken. So, it is moving from, as you have seen, it is moving from A1 to A2. So, this is what is happening. And before starting the overtaking operation, it has to look at a suitable gap. So, that suitable gap, if you see that gap was defined as C1D. So, we are talking about this gap, and these gaps are going to be with respect to the vehicles which are coming from the opposite direction. So, that this vehicle, if desires to overtake, can shift to the side lane, and during this period whatever the distance has been travelled is D1, we already looked at it. During overtaking operation, the overtaking vehicle accelerates to the design speed. So, it was moving initially with the speed of Vb, now it is going to Vd. So, there is going to be an acceleration A meter per second square related to this design speed at which this vehicle is going to accelerate to overtake. And this overtaking operation has to be completed in one go, and this vehicle comes back to its own lane, and there in this particular time period whatever has happened or the distance being travelled is nothing but D2. Then the another thing is that the vehicle which is being overtaken, what is the speed of that vehicle? That is V speed is being taken as 16 km per hour lower than the design speed. So, if we have the design speed as Vd and minus 16, so that is what is the speed with which this vehicle is moving, and the vehicle in the opposite direction which is coming is moving at a design speed. So, it is being considered as Vd, and it arrives just at the finish of the overtaking operation by travelling a distance D3, and as I said, there is no safety margin is being considered here. Ideally, if we look at it, then there should be a gap between the location, that is the location which we talked about as A3 and C2. So, I will go back. So, this is A3 and C2, this location I am going to talk here, and what I am saying is that there should always be a gap between these two for a more safer overtaking operation, but that is not being discussed when we are considering the calculations here related to OST. But this factor has been taken into consideration in the US guidelines S2, where it speaks of a distance to be maintained something like 30 to 60 meters between these locations A3 and C2 to provide more safety. Now, overall when we look at all of this aspect, we probably can define it into the form of three phases. One is that overtaking vehicle follows the vehicle moving ahead at a slower speed till the overtaking opportunity becomes available. So, this opportunity which is going to become available is C1D, and when it is moving ahead at a slower speed, that is Vb, and related to that the distance is D1. Overtaking vehicle shifts to the right of the leading vehicle, starts overtaking. So, there is a acceleration which is coming into picture, as well as the distance which is going to be travelled is D2, and this D2 is nothing but it is a combination of B plus 2S, where B is being moved by a distance being moved by a slow moving vehicle with the speed as Vd minus 16. An overtaking vehicle returns to the self lane safely without having collision with the vehicle which is coming from the opposite direction on the side lane, and here the distance which is being travelled is D3 at a design speed, that is Vd. So, when we are looking at these things, then all of those locations as we have marked, so they have been again fortified here in terms of the statements as I have already discussed about them. So, maybe we can quickly move through it. It simply says that there is a location from A1 to A2 and then from A2 to A3 for the vehicle which desires to move, overtake. There is also a location from C1 to C2 which is for the vehicle which is coming from the opposite direction. There is a movement between B1 and B2 which is for the slow moving vehicle. So, all of these things together are giving us a situation where the final OSD is going to be nothing but probably the sum of this D1 plus D2 plus D3 for a 2-lane 2-way road condition. So, when we talk about this, then we have to keep it in mind, then it is 2-lane 2-way road condition. So, this is what we are saying, that is the sum of D1, D2 and D3. Now, how to calculate these values is what we are going to talk next. If I look at the guidelines being given by Indian Roads Congress, then what it says is that the overtaking maneuver, that overtaking maneuver which we are talking from the first location when the vehicle comes and desiring to overtake, then it is moving slowly and following the vehicle which is to be overtaken, overtakes and then comes back. So, that is from A1 to A3, that is the total distance which is being moved by this particular vehicle. So, this takes 8 to 14 seconds depending on the design speed which varies from 30 kilometers per hour to 100 kilometers per hour. So, at a speed of 30 kilometers per hour it is 8 seconds, at a speed of 400 kilometers per hour it is 14 seconds. In between also the values are there, and if you remember we talked about the overtaking maneuver time under the factors, and there we have discussed that for a speed of 40, 50, 60, 80 and 100 what are going to be the values of OMT, that is what we have talked as 8 to 14 seconds. Then out of this total time of 8 to 14 seconds, it is been assumed that the vehicle, when it is simply following the vehicle which is to be overtaken, that is vehicle B, during that time period 1/3 of the time is spent, and the rest of the 2/3 of the time is being spent in finally actually overtaking the vehicle, that means moving from A2 to A3. So, this is the division of our 8 to 14 seconds, this is what we are looking at. So, we will talk as 1/3 and 2/3 condition, and this is what total is 8 to 14. Now, during this condition we have also have a vehicle which is coming from the opposite direction, and this vehicle which is coming from the opposite direction, instead of considering from the location from A1 to A3 for the vehicle A when the overtaking was thought of and then implemented, instead of that what we are considering is we are considering 2/3 of the total overtaking maneuver time, which is 8 to 14 seconds, in which the vehicle is going to move from C1 to C2. So, if this is the case, then we have overtaking sight distance is the distance D1 plus D2 which is travelled by overtaking vehicle in the overtaking maneuver time of 8 to 14 seconds, plus distance travelled D3 by the vehicle coming from opposite direction in 2/3 of the overtaking maneuver time. So, design speed multiplied by OMT is what is the first thing, and the design speed multiplied by 2/3 of the OMT is the another one, and if we take them together, then this can be written as the OSD is nothing but is equivalent to design speed multiplied by 1.67 times of the overtaking maneuver time, and which is 8 to 14 seconds. So, this is how the OSD can be calculated. Now, you can see that OSD is being calculated for different design speeds changing from 40 to 100 kilometers per hour, and here if we have taken 30 here, then this overtaking maneuver time would have been 8 seconds. So, for 40 it is 9, for 50 it is 10, for 60 10.8, for 65 it is 11.5, for 80 it is 12.5 and 100 it is 14, that is what is the values being already specified by Indian Road Congress. If we take 2/3 of it, then these values are going to be there. So, the summation is 15 to 23 seconds, and this summation this becomes totally as 1.67 times. So, this is being considered along with the design speed, and what are the values which we are going is 165 to 640 meters as the overtaking sight distances. Sometimes you can create your thumb rules also, means you can see that if it is 40, so we are talking about 4 times plus 5, if it is 50 then you talk about say 4.5 times plus 10, if you talk about 60 it is 5 times, if you talk about 80 then it is 6 times minus 10, and if you are about 100 then again it is 6.5 times minus 10 is how usually those values can also be remembered. Now, when we are talking about this overtaking sight distance and the overtaking maneuvers, things which are going to be involved here are simply vehicles. So, you have one car which is moving from this side in this direction, and there is another car which is coming from the another direction, and that is where whatever is the eye level we are talking here, which we have talked in the case of SSD as the object versus the eye level of the driver, here this becomes both equal, and that means we are talking about the eye level of the driver for vehicle as well as for an object. So, both of the values are going to be 1.2 meters. So, that is another change with respect to SSD if we are comparing them. Now, what happens on the gradient? Now, when the vehicles are moving on a gradient of any value theta, and there is a vehicle which is moving ahead like this, so what is going to be the effect of this gradient is the speed is going to reduce. And if you have another vehicle which is there and which is going to be overtaken, so if we are talking about this as V1 and we are talking about this as V2, then the speed of this vehicle is also going to be reduced. So, the effect is similar in the on those vehicles which are moving in the same direction, but there is a vehicle which is coming from the opposite direction on a downgrade. In that case, the speeds are going to increase because of the effect of the weight and its component working in this direction towards the downgrade. But all of these effects are going to be similar, and that is the reason that we are not considering the effect of gradients in the case of overtaking sight distances. Whatever are the overtaking sight distances which we have calculated for the leveled condition, we are going to consider that only. Now, what are the various different conditions in which the OSD has to be made available, or there may be some other problems which are associated with that, is what is written here. What it says is that on a single or a two lane carriageway with a two way traffic, as far as possible we should try to provide OSD. If you have isolated over bridges, then there also OSD should be provided, because in the case of isolated over bridges the speeds may be a bit more, but if they are falling within the built up area, then we can control and we can provide that overtaking may not be allowed on the bridges. In the case of summit vertical curves, when you are going on something like this, so here also the overtaking sight distance, if it is maintained, then it will ensure the safety, even it will ensure the safety in terms of the SSD also, because that will impact that value. Or if there are any easy sections of the terrain, because in all of these cases the speed is going to increase and we should provide a safe movement of all these vehicles. In the case of divided highways with 4 or more lanes, there is no need of providing OSD, and I have shown you the photograph in the very starting for this, where there are ample opportunities to overtake because of the lanes which can be designated by the speed. And if there is a vehicle which is desiring to overtake a slow moving vehicle and the slow moving vehicle moves in the designated lane, so those opportunities are available. So, OSD is not as such looked in these cases. But when you are not providing OSD, then what? Then one thing which we need to ensure is that at least the intermediate sight distance should be there, and because this intermediate sight distance is less than OSD, that means this is going to transform into a restriction in the design speed, and that restriction in the design speed should be communicated to the driver by way of providing the appropriate sign. And these speed limits, whatever we are going to provide, and we are saying that you can do the overtaking, then they should be such that the overtaking can be done with the complete safety. It should not create any hazardous situation. But still there may be locations where even the intermediate sight distance is not being possible to provide, and therefore the opportunity to do the overtaking with intermediate sight distance is not there. In such cases, no overtaking zones needs to be specified. And with these no overtaking zones are specified, we have to install the signs which defines that you are not supposed to overtake, as well as we can utilize the pavement markings which are usually yellow in color, they can also be utilized to inform the driver that on this particular section the overtaking is not being allowed. Let us have an example here. In this example, we are going to calculate the OSD for a design speed of 100 kilometers per hour, and the maneuver time is given as 14 seconds, and we have three conditions being given. One is two lane two way, another is longitudinal gradient on this two lane two way carriageway as of 1%, another one is a divided carriageway. So, the very first thing we need to calculate is the values D1, D2 and D3. If we go with the IRC guidelines, so D1 and D2, they are going to be traveled in the OMT at a design speed, and there is a 2/3 of the OMT for the distance D3 again at a design speed. This we have already discussed. If we go with this, then the D1 and D2 is design speed into OMT, and what we get is 389.2 meters. If we talk about D3, then it is related to 2/3 of OMT. So, what we get is 260.76 meters, and the total together is going to be 649.96 or roughly 650 meters, and this 650 meters, because we are considering all the three components here, this is for two lane two way carriageway. But if we have a two lane two way carriageway which is provided with a 1% gradient, we discussed that we are not considering the effect of the gradient, and therefore, this value of 649.96 meters remains valid. When we are talking about a 4 lane two way divided carriageway, in this case there is no traffic which is coming from the opposite direction. So, the D3 is not being considered, and we have D1 and D2, and for D1 and D2 the value is 389.2 meters. So, we can think about providing this, but what we have discussed is in the case of divided carriageway with 4 or more lanes, OSDs are usually not provided. So, what we can do is we can provide twice of SSD, which is going to be good enough to provide the opportunity to pass a vehicle in these situations. So, this is how we can do under different given conditions the calculations of OSD, and we can implement those values. Now, let us come to the overtaking zone. Now, we talked about that there is no opportunity for the drivers who are desirous to do overtaking of a slow moving vehicle, and then it is going to be a problematic situation for them. They will feel frustration. So, what we need to do that on such sections where these problems are there, we should try to provide the overtaking zone. So, what is this overtaking zone? Is a designated location at which maybe by way of provision of an extra width in a particular direction, we are giving ample opportunities for the fast moving vehicles to overtake a slow moving vehicle. So, initially the vehicles have been coming in the same lane because there was no opportunity, but now when it happens, so there is a possibility that the vehicle can be here and the vehicle can also be here, considering the more width being provided in terms of the number of lanes, and therefore, the opportunity to overtake is there. So, these locations where these opportunities are being provided, they are overtaking zones. Now, what is the specification of providing this overtaking zone is being shown in this sketch. What it says is that you are on a restricted section and there is an overtaking zone going to be there ahead. So, therefore, a sign S1 is to be provided which says that the overtaking zone ahead, and this is provided at a distance of 1 times of the overtaking sight distance from the start of the overtaking zone. So, the same thing is being done on the other side. You have S1 here, and that is at a distance of OSD from the start of the overtaking zone when the vehicles are coming from this direction. Now, when you talk inside, then inside also before the end of the overtaking zone, we have to tell that this overtaking zone is going to end, and therefore, there is another sign which says the end of the overtaking zone, again being provided at a distance of OSD. The same is being done in the other direction also. So, a vehicle gets into it. Here is one OSD which is there. Now, what we are trying to provide is at least 2 opportunities for overtaking. So, if there are at least 2 opportunities for overtaking in this form, that means the total distance which is going to be there is minimum 3 times the OSD, but if we can provide desirably 4 such opportunities along this section, then it will provide the 5 times of the OSD as a length of this overtaking zone, and that is how we try to plan intermittently wherever these opportunities are there if our road has more of the restricted conditions. Let us look at an example here. So, here this is a 2-lane carriageway, two-way traffic is there, design speed is 80 kilometer per hour, the OMT is given as 12.5 seconds. What it says is the distance which is visible ahead is 400 meters and we need to examine the OSD in this case. Now, it is a 2-lane two-way traffic, it means D1, D2, D3 all are going to be considered and that is where the formula is design speed into 1.67 into OMT and what we get is 464.26 meter as OSD, but what we have is 400 meters only. So, when we have 400 meters then what we need to do is the restrictions needs to be employed and the restriction one which is being thought here is that let us restrict the speed to 70 kilometers per hour and see what this value of OSD is going to be. So, we calculated 0.278 into 70 into 1.67 into 11.83 which is nothing but it is an interpolated value for 70 kilometers per hour speed and this gives us 384.45 meter which is less than 400 meters. It means now the safety is being ensured. So, we have to go with the limit on the speed as 70 kilometers per hour and which needs to be told by way of providing the speed limit signs. This is another example with which we are going to close and it talks about that overtaking is not allowed on a 2-lane two-way road, restricted conditions, traffic moving at a speed of 50 kilometer per hour. We have to look at and find out that what type of a overtaking zone needs to be provided. The overtaking maneuver time at 50 kilometer per hour is 10 seconds if it is maintained. So, if we go with that what we get is 250 meters roughly as the overtaking sight distance which needs to be provided. So, it says that you have a 2-lane system. So, this is a 2-lane system. Now, we are going to provide an overtaking zone. So, this system keeps going, we have an additional lane being provided here. So, now what should be the size of this? The size of this is going to be 250 into 3 at a minimum level or 250 into 5 at a desirable level. So, this is minimum, this is desirable. We are going to provide a sign here at again a distance of 250 meters. We are going to provide a sign S1 here again at a distance of 250 meters and similarly there is going to be a sign here S2 and a sign here S2 which is again on 250 meters and that is how our overtaking zone can be shown. With this we come to the end of this interaction and we will be continuing discussing the sight distance on other conditions like the curves and intersections. Till then, thank you and bye.